Okay, let's see my solution. So just now we stop here. What we want to do is we decided we want to use the worst radius and worst concavity, and those are the two features I want to select. So I only select those two columns, and after that, I also added the target column as the target here. So target column is added. And the next part, this is how we want to do the masking. Okay, so we want to select all the records with the target equals 0, and then we apply this mask to the dataset. So we got all the lines or all the records with the target equals 0. And after that, if you want to select the worst radius, and then we will select the worst radius of all the records with the target equals 0. Okay, so why do we want to do that? Because eventually what we are trying to do is we want to separate the zeros and the ones. And for the zeros, we want to get the x-axis and the y-axis, and then for the ones, we want to get the x-axis and the y-axis, and then we want to do two scatter plots. So this is the first scatter plot, and then we are selecting the target equals 0, and then we are taking the worst radius, and we are doing the same thing again, and then we are taking the worst concavity, because those are going to be used as the x and y axis, right? So the first one, we are going to use the blue square, BS. So BS here means blue squares, okay? And then we are using the label as a 0. And the same thing we want for the green triangles, and they are the class 1. And after that, we have this plot. Okay, the next part is we create a linear SVM and with the C as a point 0, and we also need to use the standard scalar. And after that, so we want to use this part of the code because we have to convert the scaled features back into the unscaled original features. And after that, we want to plot the decision boundaries. And after we have the decision boundaries and we highlight all the support vectors, we should have a plot like this. Okay, so we want to do something quite similar, and that is, but we want to use a very large C value here. And the rest of the part of the code, for example, this part, this is exactly the same as we have before, and we want to use this part of code to visualize the decision boundaries again, and we will see a decision boundary like this. So as you can see, this is a much narrower decision boundary. And even though this is a much narrower decision boundary, as you can see, this is a messy dataset, especially if you're only using those two features. So I suspect the decision boundary, no matter if we are using a wider margin or a narrow margin, they won't work that well. Okay, so a very quick sum up. If you're lucky enough and we have two classes and they are linearly separable, and what we can do is we can use a hard margin classification. Hard margin classification is we want to draw a margin, and this margin should be able to separate two classes perfectly. And in this case, we can say, okay, so for the samples which supports the edges of the margin, and they are support vectors. And the problem is if you're doing a hard margin classification, and sometimes if we add one more noise data, and then the hard margin classification may not be doable anymore, or if it is still doable, but the margin will be changed a lot by just one outliers. So if we don't like the hard margin classification and we want to try to use the soft margin classification, we are still trying to find a linear margin between two classes. However, we can allow some of the samples to stay inside the margin. So or the violators of the linear margin. So we want to use the C hyperparameter to control that. So if you want to use a small c, we will have a wider margin with more margin violations. Or if you want to use a large c, we will have small margins and fewer margin violators. Okay, so that's it for today. We only talk about the linear soft margin support vector classifications, and there are more topics related to SVM, and I will see you guys tomorrow. Okay, bye.